So that decreases our thirst. And we don't secrete ADH. So what are we going to do? What's this going to do to our urine volume if we don't secrete ADH, right? I'm just going to review what we've learned before, but if we decrease our thirst and ADH secretion, we should have a high volume of dilute urine, right? All right. So what are some of why would we have changes in osmolality, right? Let's think about some of the things that might cause this, right? So increase in osmolality of our ECF can occur. What if you're profusely sweating? You're sweating like crazy. You will lose some solutes, but you lose a lot of water in sweating, okay? Or if you have excess alcohol consumption, okay? So this would really increase the osmolality. Even though you have fluid, you're putting a lot of solutes in your body, okay? And water loss starts to become elevated above normal in both of these situations, okay? If we decrease our extracellular fluid, here's an example of what might happen in this situation. You drink a lot of water really quickly, or you're just drinking a huge volume of water. This will reduce the osmolality of our ECF. And so therefore, that would decrease our thirst and ADH secretion. So let's take a look at this image, right? What we're looking at here, this is the pituitary gland. And you see this is the posterior pituitary, and it says, if you have increased osmolality or a large decrease in blood pressure, both of those would stimulate ADH secretion, which would travel from the posterior pituitary all the way to the kidneys to increase our water reabsorption. And as a result, would then decrease osmolality and increase our blood pressure. Okay, it's just reviewing what we had done before. It says here, blood osmolality regulation. Let's look at our negative feedback mechanisms here. We see blood osmolality in our normal range. Okay, doing fine. And then it goes up, blood osmolality increases. Remember we said that means we have a higher solute concentration than normal. So I'm going to try to zoom in here a little bit more so you can read it. It says, osmoreceptors in the hypothalamus detect the increase in the blood osmolality, signal the posterior pituitary to secrete ADH, which causes thirst. This also changes the permeability of the distal convoluted tubule and collecting ducts to water. We change our water reabsorption. We reabsorb more water, and water consumption increases. So that would drop our blood osmolality and get it back to normal. Okay. On the reverse, if blood osmolality decreases, that means we're diluting the blood. Okay, so osmoreceptors in the hypothalamus detect the decrease in blood osmolality, signal the posterior pituitary to reduce ADH secretion, and that reduces our thirst response. So you do less water reabsorption at the distal convoluted tubule and the collecting duct, and we don't drink